All right, another concept that's still in 2.2, that section that's more on functions, is the idea of what a difference quotient actually is. And so when I did that little handout with function notation that had 3 columns, I was actually trying to lead you towards being able to evaluate, be able to find and simplify a difference quotient. I just didn't really focus on the fact that's what it was. Okay, so I wanted to just share that with you. So when you have a function, that's what's indicated in blue right here. This is my function, right? Oops, can't write off the side of it. All right, so my function is the blue graph that you see. All right, so when I'm looking at that function, I can't talk about the slope of that because that blue function is not a straight line. But what I can do is talk about the slope from one point to another, from A to B, okay? So I want you first to kind of recall something about slope that you should already have some experience with. The slope of the line from point A to point B, okay? So if I needed that, what I could do is think about how point A is an ordered pair, and we could talk about the x coordinate of that point being like x sub 1. That little subscript is just telling you it's an x coordinate, and I'm just thinking about point A as being the first point we're talking about, so that's why I used a 1. And if I go up from the x-axis to point A and then go across to the y, I'm going to call y1 the y coordinate matched up with that. And then the coordinates of point B would be x2, y2. So even though I can't talk about the slope of the function because it's not linear, I can look at I could take 2 particular points on that function and look at the slope of the line connecting them. And then it would turn out to be that usual slope formula you're used to, y2 minus y1 over x2 minus x1. Okay? All right, now, in the picture right below that one, what I'm doing is changing to function notation. So I'm still going to be looking at the slope of the line from A to B, so I still want to think about it that way. But what's going to change is instead of using x1 and y1, x2 and y2, I'm going to just let x be the x coordinate of point A, and then when I hit the function and I go across, instead of saying y1, I'm going to call that, the y coordinate matched up with that, is f of x. So it's like the output of the function at A would be f of x. And then instead of using x2 for another x coordinate, what I'm going to do is imagine just adding a small number. That h, just think of it like a small quantity being added to the x. Then this spot right here would be x plus h. And then if I go and I evaluate the function, the y value would be f of x plus h. Okay. So this is just like x1, y1. This one is just like x2, y2. It's just in terms of just using function notation instead of x's and y's. I'm using x and f of x. Okay? So if you consider what we did earlier, then that means that slope formula changes a little bit because y2 is now f of x plus h. y1 is f of x, and I'm supposed to subtract those. And then the denominator is supposed to be the x sub 2, and x sub 2 is x plus h. And the x value of point A is just x. Now there's a little more simplifying I can do, not much. The numerator You can't distribute that f. That's not what that means. Remember, that's f of this input value. It's not the same as f of x plus f of h. So you can't really distribute the f and then simplify the numerator. But in the denominator, x, take away x, those would cancel out, and you'd have just h right there. Okay? So this thing they call the difference quotient, this expression they call the difference quotient, is really just the slope of the line from one point to another. Okay? Later, you'll understand more about that concept. It's the slope or the average rate of change of the graph from A to B. It's the slope of the line from A to B, but that's the same as the average rate of change of the function from A to B as well. All right? So that expression that we encountered on that handout that had those 3 columns, what I was asking you to learn how to evaluate actually is what they call the difference quotient. So this expression here, that's the difference quotient. Difference quotient. Okay? And what it represents is the slope of the line from A to B, okay, or the average rate of change of the function from A to B. Okay. Okay. So that expression is called the difference quotient. Okay. And it's a formula that helps you get the average rate of change of a function over an interval. Okay. All right, now just a little glimpse at well, let's go ahead and work some problems. Then I'll give you a little glimpse of what happens in calculus. You really need to be able to do this in the first couple of days of calculus. So if you can get to where you can simplify the difference quotient, then you're in good shape. The calculus part's easy. The hard part is this pre-calculus component. Okay, so let's just work on trying to find and simplify the difference quotient. So the difference quotient, that's the formula f of x plus h minus f of x over h. Think about it like a formula. It's not one thing you plug into your function. It's like find f of x plus h, and then plug that in, and then plug in your original function and subtract the two. So a good way to do it is to find f of x plus h next. So this is your input, x plus h. It goes, this original rule, remember, the original rule, it would be better if you thought about it kind of like that. Okay, remember how f is this process? And in this case, the process is square your input and subtract 9. So x plus h goes in place of the original x. You square it and subtract 9. Okay? Now, you might want to continue simplifying here. Remember how x plus h squared really means x plus h times itself. So when you FOIL that, you get x squared plus xh plus another xh plus h squared, and then minus 9. So x squared plus 2xh plus h squared minus 9. That's as far as you can get on that. All right, so now I'm ready to go plug into the formula. So the formula says you put f of x plus h in, then you put f of x in here, okay, and you subtract them. So f of x plus h, x squared plus 2xh plus h squared minus 9. F of x, x squared minus 9. All of that gets divided by h. Okay? So this is one of the places people mess up, right there. That's a minus. That negative is like a -1 that would need to get distributed. So you really have x squared plus 2xh plus h squared minus 9, then minus x squared plus 9 after you distribute that -1. Okay, so we're trying to simplify the difference quotient over here on this side. So see how the x squared and the negative x squared cancel, and so does the 9 and the -9? So at that point, I have 2xh left plus h squared divided by h. And that horizontal fraction bar means that that h needs to be divided into both of those terms, or you could think of it like factoring out an h. Since there's an h common, factor out the h, and then once it's a factor, knock out h over h would equal 1, so this would wind up simplifying to be 2x plus h. Okay, so that last part, you can factor out the h, or you could be thinking this to get that end result. That h would have to be able to be divided into both, so it would knock out one h, and then here it would knock out just one of those h's, but you'd have another h left. See, that was h times h there. So it would knock out one of them, but you'd still have an h left. So this would be your final answer for find and simplify the difference quotient. Your final answer would be 2x plus h. Okay? All right, now, that in calculus, I'm going to ask this same problem, the same type of problem, but what you're going to have to do in calculus, so let me just do this part. Here's the calculus piece. In calculus, you would do that same part, so you'd find and simplify the difference quotient and all, but then I'm going to add, like, what you would wind up doing in calculus is still doing the x plus h squared minus 9, and then minus the x squared minus 9 over h, doing all that and working it out. Okay, but there's going to be this little thing out in front, and it's going to look like this. Limit as h goes to 0. So the pre-calculus work is what we just did, getting that simplified, getting you to 2x plus h. Then you just want the limit of that. It's called finding the limit as h goes to 0 is what you're going to wind up doing in calculus. So that's going to wind up being 2x when you're finished. So the calculus piece is plugging in the 0 for h and getting 2x. That's the only new part when you get to calculus. So if you can do the pre-calculus part, which is getting from here to here, okay, that's a lot of algebra that you have to remember how to do. Then you're kind of home free when I ask you to do this in calculus. And what's going on, or the difference is, this 2x plus h is the average rate of change between any 2 points. And this right here is the instantaneous rate of change at a particular, can be used to find the instantaneous rate of change at a particular point. So in pre-calculus, you do the average rate of change, okay, and you could figure out what that would be at a particular point. In calculus, your job is going to get the instantaneous rate of change. Okay, I kind of said that wrong. It's average rate of change from one point to another in pre-cal. Okay, so that concept of getting the instantaneous rate of change, that's really the derivative of the function. So that actually is the derivative That's the derivative of the function, the original function. Okay? All right. So you don't really need to know all of that, but I just wanted you to have a sense of how important it is. You know, we start with slope in like an elementary algebra class. We get to difference quotients when we get to a pre-calculus class and we're talking about functions. And when we get to calculus, we're going to talk about the derivative, which is really just the limit of that difference quotient as h goes to 0. Okay, so they're all connected. All right, let's try another one. All right, let's see. Number 11. We're still trying to evaluate that same formula. So find f of x plus h first. Plug in the x plus h. Go ahead and distribute the 5, negative 5. Okay, then think about the formula. So you're going to put f of x plus h, which is negative 5x minus 5h plus 3. You're going to subtract from that the original function, negative 5x plus 3, all of that getting divided by h. Okay? So that's negative 5x minus 5h plus 3. And then remember this negative is like a negative 1 that would have to get distributed to those two terms. So this becomes plus 5x minus 3. Okay, all of that's over h. Keep simplifying. So the 5x and the negative 5x cancel. The 3 and the negative 3 cancel. Okay. So that leaves us just negative 5h over h. There's times there, so I can cancel out the h's, and I get just negative 5. And then that would be your answer if they said find and simplify the difference quotient. All right, let's try one more. Okay, this one's just a little messier. All right, so find and simplify the difference quotient. First, go ahead and get f of x plus h worked out. That means everywhere there was an x, you're putting an x plus h, right? So in place of the x's here, we have x plus h, okay? Now, that x plus h quantity squared really means that has to be FOILed out. So you'd have 3. Go ahead and FOIL that out. X squared plus 2xh plus h squared. Remember how the middle term comes from xh and another xh? So that would turn out to be 2xh. Okay, now let me bring down the rest. I usually do the x plus h squared first, then distribute if there's a constant that needs to be distributed. Do that now. But it stops there. Now I'm just bringing the rest of the terms down. All right, now I'm ready for the difference quotient. Put in the f of x plus h in that top left spot of the formula. Remember the formula, I'm going to write it over here again. Okay. So this, all of this is the f of x plus h. Then I'm going to subtract from that my original f of x. Okay. And then all of that gets divided by h. All right, so remember the negative 1 causes these signs to change. And then let's see what we get. So I'm removing the parentheses. The first parenthesis has a 1 out in front. So that doesn't change at all, but then negative 1 gets distributed throughout. Okay. Just an h there on the bottom. Now a bunch of stuff cancels. Negative x, positive x, 3x squared, negative 3x squared, negative 8, positive 8. Okay, I'm going to move over here now. So what I have at this point is a 6xh, a 3h squared, and an h, and that's it. And that's divided by h. So here you could factor out an h if you wanted to, or since it's only a single term, you could divide by h, each term by h. So you could factor out an h, okay, or you could divide each term by h. If you are factoring out, don't forget to put a 1 there at the end, because that h would need a 1 there to wind up giving you the h that you had at this point. Okay, so either way you're thinking about it, factor out the h or divide h into every term so that you can simplify these. So the h, one of the h's cancels in each of them. H squared is really h times h. So what you wind up with is just 3 and 1h left. And then h over h doesn't go away. H divided by h is equal to 1. Okay, so that would be your answer. And then later in calculus, we would do the limit of that as h goes to 0. Okay, so all that work we did so far is the pre-calculus work. And then in calculus, we just plug in a 0 for the h, and we wind up with 6x plus 1. And 6x plus 1 turns out to be the derivative of the function. Okay? So you don't really have to know that here, but I'd just like you to have a sense of where it's going.